Hello dear students, we are going to solve a numerical problem related to Young's double slit experiment. The question is, coherent light with wavelength 500 nm passes through narrow slits separated by 0.3 mm at a distance from the slits large compared to their separation. What is phase difference in radians if the light from the two slits makes an angle 23 degree from the center line? Now solution. Let us understand the question with the help of a diagram. Suppose this is monochromatic source of light emitting light of wavelength 500 nm, that is 500 into 10 to minus 9 meter. Slits A and B, which are acting as coherent sources, are separated by distance 0.34 millimeter, which is 0.34 into 10 to minus 3 meter. At any point P on the screen, the center line PC makes angle 23 degree from horizontal, where P is a point on the screen. We have to find the phase difference in radians between the light waves coming from coherent sources B and A to point P. Now, while discussing the theory of Young's double slit experiment, we had taken this angle, which is geometrically equal to this angle theta, to be very small. Therefore, sin theta was approximated at theta. But in this case, sin theta cannot be approximated at theta, because theta, which is 23 degree, is large angle. Now, to find out the path difference between rays coming from B and A at P, if we take distance AP is equal to PN from BN, then the path difference delta x will be equal to BP minus AP, which can be written as BN plus NP, BN plus NP minus AP, because AP is equal to PN. Therefore, AP and PN can be cancelled out, and therefore we get delta x is equal to BN, which is the path difference. Now, in this triangle, sin 23 will be equal to perpendicular BN upon hypotenuse AB. Therefore, sin theta will be equal to BN upon AB. BN is equal to delta x, path difference, and AB is equal to D. Therefore, sin 23 will be equal to delta x upon D, which gives delta x as D sin 23, which is the path difference between the two waves coming from point B and point A at point P on the screen. Now we know phase difference is delta phi is equal to 2 pi upon lambda times path difference. So it will be 2 pi into delta x is D sin theta, D sin 23 upon this lambda, and on putting the corresponding values, we get delta phi as 1669.4 radians after calculation, which is the required phase difference in radians.